Hello, and welcome to the first edition of Kubermatic Office Hours. Today, we will try to answer all your questions you have about the Kubernetes platform, and KubeOne. And you feel free to ask any questions you have about those products. You can do it on YouTube chat, and feel free to drop your questions immediately once you have, and we will go through them in between sessions and make sure to answer them. Uh, let's wait 2 or 3 more minutes for everyone to join over the new link. We had some technical difficulties, but everything should be resolved now. However, we just have a new streaming link on YouTube. In meanwhile, if you have any questions before we start, feel free to ask them in the YouTube chat. We will wait 1 more minute. Okay, so let's get started. For today, we have prepared a couple of sessions where we will show some of the recent developments we have and some of the recent developments happening in the Kubernetes community. Our first session for today is Kubernetes community update, where we are going to talk a little bit what's new in Kubernetes 1.20 and what's going to happen in Kubernetes 1.21. So let's get started. I have shared my screen. I hope that you can see it. And let's go. So the first topic of today is what's new in Kubernetes 1.20. So Kubernetes 1.20, called the Raddest release, was the final release of 2020. And it is one of the most feature-dense releases so far. We had 42 enhancements included in the release. Many of the features graduating to stable, to beta stability, and also being introducing alpha features. There is a lot of new stuff that we are going to cover today. And I have wanted to mention that Kubernetes platform 2.16 that went out a few days ago, and Kubernetes KubeOne v1.2 that is planned for the upcoming weeks, brings support for the Kubernetes 1.20. And to start with the news that probably brought the most attention is that Docker and Docker Stream is deprecated starting with Kubernetes 1.20. What this actually means, it means that you will not be able to run Docker on Kubernetes nodes. Instead, you will have to use Kubernetes container runtime interface compatible runtime. Such runtime includes Containerd and CRI-O. The removal of Docker support is supposed to happen between Kubernetes 1.22 and 1.23. It is still to be decided which is going to be the final release to be removed support, but we are going to probably know a little bit more about this in next 2 releases. Another one breaking change for some users is that exit probe timeout handling has been changed to fix a long-standing bug. The bug was that exit probe timeouts were not really affected. So previously, the timeout seconds field was not respected at all. Instead, all probes would run indefinitely, even past their configured deadline until a result was returned. Now it is changed, so the default value is 1 second for exit probes. And if your probes are taking more than 1 second to execute, then your pod might be crashing. So make sure to check your timeout seconds field for your pods running exit probes to make sure that you're on the safe side. Another deprecation and removal is pod presets. The pod preset features was removed in Kubernetes 1.20 with no built-in replacement. As an alternative, mutating admission webhook can be used and are recommended by upstream Kubernetes. And those are some changes we wanted to highlight today. And if you want to learn more about Kubernetes 1.20 release before you get started with it, we recommend checking out the announcement blog post and the changelog. And we will share the links to those tools resources in YouTube chat. And next topic is Kubernetes 1.21 release update. The Kubernetes 1.21 release is currently work in progress, and right now we are at the week 6 of the release cycle. There are 14 weeks in total, so this means that we are at about the half of the release cycle. Some of the milestones, or how are we standing, is that we had enhancements freeze February 9th, so no new proposals for features, improvements, and similar will be accepted. Then after that, we have beta 0 release scheduled for next Tuesday, February 23rd. After that, we have code freeze scheduled for March 9th. And after that period, no new changes from the code side will be accepted. Every feature that is targeting 1.21 has to be feature complete at that point. And the Kubernetes 1.24 release is scheduled for April 8th. At this point, there are 64 enhancements being tracked by the 1.21 release team. It doesn't mean that all 64 are going to make. Historically, a lot of enhancements get kicked out of the milestone because they don't manage to hit the deadlines like code freeze, but we hope that the most of those adjustments are going to make the release. And some of the highlights that we wanted to highlight about what are the upcoming features. First, I want to mention that those features are not guaranteed that will make 1.21. It depends on are they going to be implemented on time, documented, and everything else. And the first feature is ephemeral containers is graduating to beta and being enabled by default. This is a very powerful feature to call it like that because it supports advanced troubleshooting of running pods by running a new container image in a shared pod namespaces. This is right now it is alpha feature and can be enabled to be tested. And there is a kubectl debug command that can be used to run ephemeral containers. But starting with 1.21, it is going to be enabled by default. After that, we have CCM and CSI migration plan. The C cloud provider has made a plan for migrating from in-tree cloud providers to external cloud controller managers and CSI plugins. Right now, the plan is that starting with 1.23 or 1.24, the in-tree cloud providers are going to be disabled by default with an option to enable them explicitly. And starting with 1.25 or 1.26, it's still to be decided, it is going to be removed with no option to enable in-tree providers. Besides that, we have graceful node shutdown graduating to beta. This is a new feature that has been added to 1.20, if I remember correctly, which can detect and gracefully terminate pods if a node is being shut down. This can be useful in scenarios such as some problems, upgrades, and so on. And IPv4 and IPv6 dual stack support is graduating to beta. And something that has been announced just recently is that it is planned that starting with Kubernetes 1.21, the pod security policy, PSP, is going to be deprecated. So far, it is mentioned that removal will be planned for Kubernetes 1.25, and at this stage, with no built-in replacement, but projects such as Open Policy Agent, OPA, can be used as an alternative. We are going to see a little bit later today one session that is going to present OPA and how it works and how it can be used. And Kubernetes news of the week, or this was shared last week actually, but it is a very good reminder that V1 Beta 1 versions of CRDs is going away in 1.22. also of admission webhook configuration. You should check this blog post on Kubernetes forums. It has been also shared to Kubernetes Dev mailing list, which details some more information about what is going to happen in 1.22, what this actually means, and what you should do to migrate. And thank you for your attention. Before we start with the next session, I would ask you to ask any questions you have. And after that, I would like to give it stage to my colleague Lovro, who is going to talk a little bit about OPA.
Okay, so I think I can start now, right? Let me just share my screen. Today I will just show a short demo about how Kubermatic integrates OPA. So OPA integration is a new feature in Kubermatic. It has been introduced with 2.16. And as Mark already mentioned, the PSP, pod security policy, is getting deprecated. So I'll show a little example of how OPA can replace PSP. So maybe firstly, I'll talk a little bit about OPA. It's a very big topic, so I'll just kind of surface here. But it's an open policy agent, so it deals with policies. It allows users to create and enforce policies, which basically means rules across their whole cloud-native environment. And in Kubernetes, as we are dealing with Kubernetes, we are integrating the part of OPA which deals with Kubernetes, which is Gatekeeper. So in a nutshell, how we do it is that we allow users to create and manage the policies on the seed and master clusters of Kubernetes, and they are automatically reconciled to the user clusters which have the OPA integration enabled. Through this, users can very easily manage the gatekeeper policies across multiple clusters. So let's get to the example, and for this I'll show you a bit how the gatekeeper works. So it works by creating those policies, right? Makes sense. And those policies in gatekeeper are called constraint templates. I'll show you one now. Let's make it a little bigger. So the constraint templates define constraints, and we can see that in the first part of the constraint template, that it defines a constraint called forbid privileged. And the second part is the Rego language, which is the OPA language, which is basically the rule itself, the policy itself. So here, this touches the something that pod security policy was doing before. For the pod security policy, you could disallow creating pods which have security context privilege set to true. So basically giving them root access. And here in this language, I won't go too far into it, but you can see that there is a violation described here, and it goes through all the input containers, which can be either the containers or the init containers, and it checks if the security context privilege is true, and if yes, then it writes a message and the violation gets triggered. So how the OPA works here is that it goes through all the lines, and if each of them succeeds, it goes further. So if it comes to the message part, it means that the violation was achieved, let's say. It's a bit complicated to grasp at first, but the OPA guys have a lot of examples, and they even have a playground where you can test your legal policies. Okay, so here on the left side, I'm on the seed cluster, and I will create this PSP templates. Okay, it's created. And on the right, I'm on the user cluster. I created already a cluster with OPA enabled. And we can see here that a CRD was created, which is called forbid privileged. So this is how Gatekeeper works. It checks the constant templates which are available, and for each constant template that it sees, it creates a corresponding constraint CRD. Okay, please note also here that we are not using in the seed cluster the Gatekeeper constant templates. We are using the Kubermatic ones because we wrote just wrappers around the Gatekeeper ones, and we are thinking the Kubermatic templates, which are basically almost the same as the Gatekeeper ones, to the user clusters for the Gatekeeper. This is also so we can more easily extend the constant templates in the seed clusters and add more features around them. Okay, so let's check constraints. So we have a constraint that will go into that will be created for this cluster that I created. It will be created in the seed cluster, but in the namespace for the user cluster. And it's pretty simple. It just says what resources to match. So here just match pods, and it tells the Gatekeeper to when it sees a pod to run it through the rule and see if it violates the rule. Okay, and let's create it. Okay, it's created, and we can see that we have now a forbid privileged constraint. I created, I have prepared two YAMLs with pods. One is example where it's bad, where it's using the privileged security context. So if I try to create it, it should fail. Yeah, so you're getting an error from the server with this message here that the privileged container is not allowed in the image Nginx. But if I try to create the good policy, the good pod, which has a privilege false, it should be able to create it. Okay, it's allowed. So here we can see that easily we could just replace the pod security policy, at least for this privilege part, with OPA. And Gatekeeper has a whole library of policy, constant template examples with different regals, which all target the PSP. So it's very easy just to take them and create them in Kubermatic. I also want to show you one more thing. If you can see the error message, it says that admission webhook validation Gatekeeper denied the request. So I'll explain just a little bit how Gatekeeper works. It's kind of simple. It has a validating webhook which targets everything. So you can see that it targets all API groups, all versions, all resources for create and update. So it works like this, that it gets everything goes through it. It sends it to the controller, which is on the seed cluster. Let me show you. It's here, And the controller, based on the constraint templates and constraints which are defined, makes a decision if it will allow it or not. So here he got a pod, and because of the template and the constraints, it's checked it out through this Rigo, and it says it's not good. So I'll show you an example of what happens when the constraint is off. So now it shouldn't be there. Yeah, it's gone. So now I should be able to create the beds pod. Okay, and when I create it again, well, Gatekeeper can't do anything anymore, right? Because it's already created, so it can't forbid it, but it can do something else. Gatekeeper also has a audit component, which periodically runs audits on the existing resources, and it checks all the existing resources through the policies which are defined. So now we should be able to see the information here about the audits. Okay, it's not here yet, but it should come at one point. And basically, that's all I wanted to show about OPA integration in Kubernetes. Let me just check if, oh, okay. You can see that something called violations appeared, and it's a good way to show users when the policies are created on an already existing cluster, that some of their resources are violating the rules that are set. So here it says that there's one violation of the constraint, and that the pod Nginx is violating the rule that the privileged container is not allowed. And that's all of what I wanted to say for today. Thanks you for your attention. If you have any questions, please write them in the chat.
So if you have any question about the OPA, feel to ask them in the chat. In meanwhile, I will answer the question that we have got in meanwhile about how will the migration from in-tree providers to external cloud controller managers work. In general case, the C-Cloud provider has announced several feature gates that are going to help in this process. So you can disable the in-tree cloud providers and then deploy the external cloud controller managers to be used instead. In case of KubeOne, we are planning on an automated way. So probably some CLI command that you will be able to run to do the migration for you automatically. And similar for KKP, we are currently planning a feature that you will be able to trigger the migration for CCM and CSI from the UI for existing clusters. And right now, I would like to start another session, and it is KubeOne community update, a little bit used from the KubeOne development and what we were working on since the previous release and what are we planning to do. And let me just share the screen. Okay, you should be able to see KubeOne community update presentation. And we are going to start with v1.2 status update. So KubeOne v1.2 is going to be the first minor release of this year and is planned for the upcoming weeks. Just today, we have released beta 1 of KubeOne v1.2 release, so give it a try and let us know what do you think about it. We very appreciate the feedback. Many features and improvements are included in this release, such as support for Containerd, support for Amazon AKSD, Debian support, and much more. And maybe the most important is that Kubernetes 1.20 is officially supported starting with this release. And some highlights about what we have done so far this release. The first one is that we finally support Containerd. Now that the upstream has announced that Docker is deprecated, we decided to provide Containerd as an alternative to Docker. And currently, it's only possible to use Containerd for creating new clusters. Migration for existing cluster is something planned for the future, and we are going to keep you all updated about that. So we have, as an answer to the Docker deprecation, we have decided to change a little bit which runtime is being used when creating new clusters. So all newly created Kubernetes 1.21 plus clusters will use Containerd by default. And we are planning to automatically migrate all clusters from Docker to Containerd, starting with Kubernetes 1.22. The automated migration is still something that is work in progress and that is being planned, but we will make sure to give an update on time so you have time to prepare it and test it. Moreover, the Containerd support works for regardless of Kubernetes versions, so you can use it with 1.17, 1.18, whichever version you run in production or in whatever environment. And we recommend using Containerd for all newly created clusters, regardless of Kubernetes version, because it is going to save you trouble from migrating from Docker to Containerd. We don't expect any trouble, but it is still going to be much easier and you're going to have a more future-proof clusters. And how it looks like, how can you actually choose Containerd? It is actually very simple. Everything you need to add to the KubeOne configuration manifest is this part highlighted in red. You need to mention container runtime and just say that Containerd is being used. And the next time you create that cluster, it is going to be using Containerd. Another feature that we are happy to announce is AKSD support and Amazon Linux 2 support. AKSD or Amazon AKS distro is a distribution from Amazon, which is based on and used by Amazon AKS product. Currently, it is only possible to use AKSD on Amazon Linux 2, and support for other operating system and providers is planned for the future. Additionally, Amazon Linux 2 works with vanilla Kubernetes, but it requires you to specify URLs to all binaries, to kubelet, kubeadm, kubectl, and CNI in the KubeOne configuration manifest using the asset configuration API. This is something we are working on, and we are working on support for package managers and hope that we are going to have it for one of the future KubeOne releases. If you want to learn more about AKSD, we recommend following the following resources. The first one is getting started with AKSD on our blog post. Then we have a recorded demo of how to deploy it. It is just 3 or 4 minutes, so you can take a look quickly if you want to learn more about it. But also, we are going to have a webinar in March, joint webinar with AWS about using Amazon AKSD and KubeOne. So if you're interested, make sure to join it. And some other highlights for the end of this update is that we now have Debian support for control plane and static working nodes. Right now, machine controller doesn't support it, but we are planning on extending it at some point later. In meanwhile, for working nodes, you can use the static working nodes feature. Support for CoreOS is removed starting with v1.2.0 beta 1 release that went out today. As an alternative, KubeOne supports Flatcar Linux, and we recommend migrating all your CoreOS clusters to Flatcar or other supported operating systems. Information about static working nodes can now be sourced from the Terraform state, is another feature that we have included in the v1.2 release. We also have 2 new API fields. The first one, registry configuration, and another one, asset configuration, which is currently in beta. And it currently works only on Amazon Linux 2 for binary assets like kubeadm, kubectl, but it works on all operating systems for image assets like Kube API server, metric server, and everything else we deploy. These two API features allows you to use custom images and image registry for control plane components. This is very important if you want to use something like proxy image repository, like to work around the Docker rate limits. So give it a try. And last for now is that go between is replaced with keep alive in vSphere Terraform example configs. This setup is now a little bit more suitable for production usage. So if you are interested in how load balancer works with providers where there is no native support or some cloud offering, make sure to check the new changes to the vSphere examples. Beside there is a lot of more changes, and you can check the changelog for the v1.2 releases to learn more about what's new. And one update from the development, we have a new feature, which is work in progress, and that we hope to include in v1.2, but it is just being planned and just being worked on. So there is no guarantees that it is actually going to make 1.2 release. A new feature is support for encryption providers, which allows you to encrypt secret data at rest. In other words, it means that the API server will store all secrets to etcd in an encrypted format. This will provide additional security and can be especially important in cases such as security compliance or something like that. Initially, the plan is that the feature will provide support for automatically generating the configuration file and the encryption secret, support for automated key rotation and rewriting all secrets in case the encryption secret is changed, and support for using the custom encryption configuration. Support for key management system is something that is planned for the future. As an example, in the most basic case, where KubeOne manages the encryption secret and the configuration file, enable this feature is just 3 lines of YAML in the KubeOne configuration manifest, where you define features, encryption providers, and make sure enable is set to true. This is something that is said at the beginning, work in progress, but we hope that it's going to make it 1.2. For now, not guaranteed, but there is a good chances. Thank you for your attention. And if you have any questions, please ask them in YouTube chat. We have a question about what is the difference between AKSD and vanilla Kubernetes. Is that the biggest difference is something that is probably the most notable, is that the AKSD is following the release cycle of Amazon AKS, which means that you're going to have extended support for Kubernetes releases, similar to what is the case for Amazon AKS product, and you're going to receive security updates and everything else that is done for AKS. Looks like there are no other questions, so we will close the session a little bit earlier this time. We want to thank everyone for joining today. I hope that you liked the first edition of Kubernetes Office Hours. If you have any feedback for us, feel free to let us know. But also, most important, if you have any questions, please feel free to reach to us. And we have the Kubernetes community Slack channel. And you can also, yeah. So thank you for joining today, and bye-bye.